In this video we are going to model the nozzle of the vertical vessel. We already modeled the body of this vessel in the previous video, and now we are going to model all the flanges and nozzles of this vertical vessel. First, we are going to model the sump or boot nozzle in the bottom head. Choose the head and click on nozzle icon, name it to sump, we are going to see if any information about the material of the sump, and it's likely to be the same as shell or body of the vessel. We choose the same material for the boot because it's going to be shell from plate, and we choose the thickness to 10. Now we convert the millimeter to inches, and the thickness is 10. We choose none for the flange because it doesn't have any flange. In the general information, it has reinforcement pad, but PVL it says that it doesn't need any pad. We're going to try to model the projection of the nozzle. We model a semi-elliptical and joint it to the sump nozzle. It has 10 millimeter thickness before forming. We name it to sump head. And change the related information in accordance to the general drawing. Set the straight flanging to 35. And it seems all set for the sump. And now we are going to model M1 nozzle, which is a manhole, and it has a blind flange at the end. It is at the 1000 elevation. So we choose the cylindrical shell 1, and name the nozzle. Naming the nozzle shall be a little complete, and it has to be guiding. We choose all the necessary information for the name of the nozzle. It is 20 inches, welt neck nozzle, and a class of 150. And the nozzle neck greater than 14 inches has the same material as the shell. It is 20 inches. And the thickness is given in the general drawing 12. And now PVL, it says that it needs reinforcement. Now I'm going to set the elevation and the layout. And the reinforcement pad properties is given in these two columns. We put the necessary information of the pad in their related boxes. It's a welt neck nozzle. For the orientation, it is better to see a top plan. And now for the projection, it is 965, but it is not right way to put the projection. We have to go through layout to put the information. Over here, it's better to go to this dialog box for put the orientation and elevation information. The angle is 90, and let's see, the projection is too large, and we have to go to the layout dialog box and set the projection correctly. It's all set. We see the vessel from top plane, and we go through the configuration and see the setting for the nozzle, and the zero angle position is at north, and the clockwise direction is for the changes in angle. So this nozzle is a manway nozzle, and it has to be it has a blind flange in accordance to these notes. In PVLit, there are two boxes that have to be checked when we have manway. So now it's more like a manway nozzle. Now let's take a look at other nozzles and see what nozzle we are going to model next. There is a N1 nozzle which penetrate inside the vessel, and a secondary nozzle goes through the ENIAC nozzle. ENIAC nozzle is a 40 inches nozzle, and a 3 inches nozzle penetrate through its blind flange. This calculation is not explicitly possible in the PVLit, and if we are going to calculate the 3 inches nozzle, we have to create a submodel for it. In this tutorial, we model only the N1 nozzle with 4 inches diameter. Add new nozzle and set its name N1. Four inches. Weld neck, raised face. Class of 150. And the material shall be the material of pipe SA 106 grade B. Select the material. And we set the thickness to minimum. In this way, PVLit consider the meal tolerance for the pipe of the nozzle neck. We set the dimension to 4 inches and the schedule of 120. We set the diameter bases to OD. It's normal for the pipe neck nozzles. And in this stage, we set the elevation to 300. And the orientation of the nozzle is 180, and the projection is 900 plus 320. Set the pad diameter and the inside projection shall be calculated from this drawing. We see how the nozzle looks like right now with the inside projection. And this nozzle has blind flange for the parent nozzle, which is the 4 inches nozzle. And then a new nozzle, we are going to model the new nozzle in shell 1. We can see the complete list of nozzles over here. And one 4 inches nozzle is modeled and it's complete. Now we see the nozzles from the nozzle table in the general drawing, and we try to model the nozzles respectively. Start with L1A, which is on shell 1. Which is the line welding neck nozzle. L1A, 2 inches line welding nozzle, 150 class, and the material shall be a forged material SA 105, a common material for flanges and forging. The thickness and the projection is given in these 2 columns. First, material is selected. For this type of nozzle, the ID basis is better choice. Set the thickness and the elevation because elevation is greater than the length of the component shell 2, PVLit prompts with this warning. We have to calculate the elevation correctly. With respect to these dimensions. Now it's time to set the layout angle. We see the top plan over here, L1A is at 5 degrees and the projection is 865. We set the flange to line welding and the class is correct. Click OK. And the nozzle is set at the right orientation as the general drawing. L1B nozzle is the same as the nozzle LA, L1A, and now we can use some helpful options of the PVLit. Set the name. We can choose this option to create a nozzle the same as L1A. The only difference is on the name and the orientation and elevation that have to be set correctly in accordance to general drawing. The orientation is the same as L1. Because these two nozzles are for level gauge and they have to be in the same orientation. Now we go through the next nozzle L2A and the elevation is given over here 1850. new nozzle, click on add new nozzle, because if we don't click on this icon, PVLit will replace the new nozzle on the previous nozzle, on the old nozzle, and it doesn't create a new nozzle. Set the size 3/4. Line welding nozzle with class 150, and set the thickness. Now the elevation has to be set with some calculation. Set the elevation correctly. For the orientation, we go through top plan. L to A and L to B are at the same orientation, 255 degrees. And line welding neck, set the projection to 865. L to B, same as L to A, but in a different elevation. Select shell 1 and create a new nozzle. Add new nozzle, or click on add new nozzle, just like L2A, and the elevation needs to be set again, 150. Here's a mistake I've taken in the modeling of this vessel, and I've taken the datum 50 millimeter under the weld line of the bottom head, and it has to be 35, not 50, and that's because the elevation from node is not correctly written when I'm modeling the nozzles. Now we see the nozzle list over here, and all necessary properties of the nozzles and flanges are in this list. And we can modify the name of the nozzle in the list. Next nozzle is L3A. L3A, which is on the boot nozzle or boot shell, and we are going to model it on the boot. Click on the nozzle, in this manner. It doesn't resolve anything because the boot itself is a nozzle, and we have to choose the head, bottom head, to create a new nozzle, and click is this nozzle connected to another nozzle. First, select a name for it in accordance to general drawing. And fill all the necessary properties for the nozzle. The material is SA105, and the parent nozzle is sump. And we are going to set the all necessary information for correct modeling of the L3A nozzle. Of course, modeling this type of nozzle might be a little tricky because it is welded to the other nozzle, and it might be a little weird to model this type of nozzle. And understanding all the boxes in the nozzle dialog box is necessary to model correctly this type of nozzle. L3A is at 340 degrees. It is considered a radial nozzle. (450) from the center line of the vessel and the boot nozzle. And this type of warning shows that we are selecting improper magnitude to the box. It's better to put the projection number explicitly in the first page of the nozzle properties. It's 450 minus the radius of the boot nozzle. Next nozzle is L3B. The same process for L3A is taken for L3B, and it's like same as L3A, and the only thing that differ is the elevation and the name. The orientation of these two nozzles are the same. The elevation is 1000 minus 1050, and we are trying to gain a correct number for it. $1,370 minus 35 minus 350. It's the projection of the sump, and if the projection of the sump is correctly set, the elevation of the L3 nozzles is correctly set. Next nozzle is M1, which is already modeled. Next nozzle is N1, same, it is modeled. N2, which is a 1-inch nozzle. Of course, these types of nozzles are small opening, but in this tutorial we are not ignoring them and model all the nozzles in the vessel. Choose a name. N2 nozzle is a 1-inch nozzle line welding neck, 150 class. Set the name. It's 1 inch. The thickness is 12.85. And the elevation and orientation is given in the elevation and orientation views of the general drawing. And to nozzle, it's at 1800 elevation. Minus this is a difference in 680 elevation of the shell too. The only thing is on the layout, which is mistakenly selected again, and we have to edit it in the layout orientation. It's 865. It is recommended to set the projection always in layout box. The next nozzle is entry nozzle, which is a 2 inches line welding neck with the class of 150. The thickness is 15.85. which has been selected from the previous nozzle, and it doesn't have any parent nozzle. The orientation of entry nozzle is 270 degrees. At the bottom head. Eight hundred 180, sorry. Sometimes the layout is inactive and we have to input the thickness again to active it. It's a hillside nozzle, and we have to set the L dimension for it, and it is given in the DWG, in the general drawing, and the projection is given in the table nozzle. First we take a look at the nozzle and how it looks like. Now we set the projection. Projection in accordance to the drawing is 450. Of course, the projection in the drawing is given from the tangent line, but the thing that we are going to set in PVLit needs to add it by 35, which is a straight flanging. Now it's time to model the N4 nozzle, which is a 2 inches nozzle. For that we choose the sump head and add a new nozzle, N4, 2 inches, line welding neck with a class of 150. SA105 is the material, and we set the size, we set the actual for the thickness, and the thickness is given in the nozzle table, which is 15.85. It doesn't need any modification in the orientation, just needs the projection needs to be set. A radial nozzle with the projection of 290. Save the model. And 5 nozzle, which is a line welding neck nozzle. At the top head, select the top head and click on new nozzle. And 5 2 inches line welding neck with the class of 150. SA105 is the material, actual for the thickness and none for the schedule, because it's not a pipe, it's a forge. It's a radial nozzle with projection from the tangent line 550. We forgot to set the N4 nozzle to line welding neck, and we check the other nozzles as well. All set for N5, and we go to the next nozzle, P1. Again, a line welding nozzle. P1, three over 5 inches line welding neck with 150 class of pressure rating. Set the thickness to 9.5 millimeter. It's a hillside nozzle. And the orientation is given in the top plan of the general drawing. P1 it is given by the dimension, and we are going to try to set the dimension over here, and the projection is the elevation in the elevation view 435. All set, click OK, and again this process means that we gave a wrong value to PV Elite, and we have to find out what is wrong with these numbers. Let's see and check what is wrong with the numbers. We go to layout again, choose the hillside, and there's a number for dimension L, and a number for angle. Again, we encounter that process. Please tell me if you know what is wrong with PV Elite and what happens in this situation. Maybe something is wrong with me. All set, and the nozzle is created. Next nozzle is R1 nozzle, which is a 3 inches welt neck nozzle on the top head. Click on the nozzle input dialog box and add a new nozzle. R1, 3 inches, and a welt neck nozzle. The material has to be 106 grade B, because the neck is a pipe, and we set the minimum to consider the mill tolerance for the manufacturing of the pipe. In this way, PV Elite consider 12% of thickness reduction in the manufacturing process. Select the red hillside nozzle and set the angle for the orientation. Nozzle R1 is at 225 degrees. It's 180, sorry, and the projection shall be taken from the DWG, and we see the DWG for the projection. complete the name of the nozzle, weld neck, with the class of 150, and it's a weld neck nozzle. Click OK, and the nozzle is created on the top head of the vessel. The last nozzle is T1. It's only shell 1. Select shell 1 and click on nozzle input. Click till we reach the add new nozzle. To avoid duplicating the nozzle over the previous nozzles. It's a line welding nozzle. .5 inches with the thickness of 14.3 and the elevation of 200. Set the layout. The projection of 865 and orientation given in the orientation view in general drawing 155 degrees. Click OK and click OK. The last nozzle is created and modeled, and we see we are going to take a look at boot nozzle again, and consider the reinforcement for this nozzle in accordance to the nozzle table given in the general drawing. Of course, PVL doesn't says that it doesn't need any reinforcement path. We run an analysis for the vessel and see what type of errors we have. It says that reinforcement limit between the nozzles are overlap. Now we have to set the reinforcement nozzle a little smaller and run the model again to see if the warning or error is solved. Set the reinforcement pad diameter a little smaller. Again, we see that the warning is given again, and we have to modify something more in PVL to resolve this error. We can manipulate the limit of reinforcement of nozzles manually. Because we are sure that there is nothing wrong with these nozzles, and without reinforcement they are already reinforced, and without reinforcement and you can rely on these nozzles. So we can try to modify the limit of reinforcement manually. And run the model again to see if the warning is resolved. There is another warning for the MAWP, which says that the MAWP is a nozzle reinforcement is governing the MAWP of this nozzle, and because the nozzle is sump is somehow given as a main component, and we are ignoring this error.